Consider the graph of y equals f of x below, that's this one here. Use the graph to produce a sketch of y equals f dashed of x and y equals f double dashed of x. So, this one is fx, this one is f dashed x, which is the gradient function dy dx. Now remember, dy dx equals 0 every time there's a turning point, and that's usually where I start with this. So what I'm going to do is identify any turning points. That looks like a horizontal point of inflection, and there looks like a minimum there. And those will be zeros on the graph of dy dx. Now remember, this one is the gradient function. So if we look at the f of x graph, the gradient here is positive. So it must be above the axis here. It's then going to become 0, and then it's going to be negative along this section with a point of inflection which appears to be around here. So that's the maximum negative gradient. It's going to do that. Now let's think about what it does at this point of inflection. The gradient's negative, 0, and then negative again. The only way it can do that is to have a maximum here. Then there's a point of inflection here, an oblique point of inflection, which means that will be the most negative the gradient gets. And then after that, the gradient is positive. Now, when we come down to the bottom graph, f double dashed x, yes, that's the second derivative of the top graph, but it's the first derivative of this one. Therefore, it's the gradient function for this graph. So we're going to produce it in the same way. Let's find the turning points. They're going to be zeros of this graph. So along this section here, the gradient is negative. So it must be below here. Then it becomes positive, and there's a point of inflection in here, which is where it will be the steepest. So that's where the gradient is its maximum positive value. Then it's going to become a negative gradient for a bit with a point of inflection in there. And then the gradient is positive, like so. Now I just want to compare the bottom graph with the top graph. So we can see that that means that the top graph should be concave down. And that's going to line up just there. And we can see that this is concave down. Then it's positive across here. And this one is concave up around this section. It then becomes concave down for a bit, corresponding to this. And then where the second derivative is positive, we've got a concave up shape.